Information is key to quality of life, to economic development, education, healthcare, public services. Without access to information, much of the world is at risk of being left behind. Today, 3 billion people worldwide have never even made a phone call. But even this basic telephone service is no longer sufficient. Increasingly, high-speed or broadband internet access is necessary to fully participate in the information age. The internet is the telecommunications network model of the future. It enables radically new kinds of communications. The internet provides an open public network over which all kinds of information can be shared. In most areas of the world today, access to the internet is so slow it's unusable, or it's simply unavailable at any price. Upgrading ground-based networks to provide broadband internet access is often not practical. Most of the world's citizens will never have broadband access to the internet through a ground-based network. Teledesic is building a global broadband internet in the sky. The company is creating the world's first network to provide affordable, high-speed internet services and access to other interactive communications worldwide. The Teledesic network consists of a constellation of hundreds of low Earth orbit, or LEO, satellites. On day one of service, Teledesic will enable broadband telecommunications access for businesses, schools, and individuals everywhere on the planet. Teledesic was founded in 1990 and is based in Kirkland, Washington, a suburb of Seattle. Teledesic represents the vision of its chairman, telecommunications pioneer Craig McCaw, and is backed by Microsoft chairman Bill Gates and the Boeing Company. For Teledesic service to be successful, it will also require committed partners from around the world.
You need to connect up everyone, including schools and hospitals all over the world. And Microsoft is working with many satellite activities. One that I'm personally involved in and I think has incredible potential is the non-geostationary systems like the one being done by Teledesic. So in a transparent way, this is an extension of the internet.
Boeing, the world's largest aerospace company, will lead the international industrial team to manufacture and launch the satellite constellation. Service is targeted to begin in 2002. Teledesic selected Boeing to be its prime contractor because of its pioneering work in space and its experience managing global alliances involving hundreds of suppliers in dozens of countries. Teledesic has received support from many countries in both the developed and developing world. In March of 1997, the United States Federal Communications Commission licensed Teledesic to build, launch, and operate the Teledesic network. There are some basic issues involved in delivering global broadband wireless services. First, why use satellites? With ground-based systems, service is more expensive the farther you go from urban areas. The cost of satellite-based service is independent of location. Also, the ability of satellites to offer bandwidth on demand means they can serve the low-intensity users for whom fiber is not economical. Second, why use low Earth orbit satellites? There are basically two types of satellites: geostationary, or GEOs, and low Earth orbit, or LEOs. To put the difference between them into perspective, the space shuttle orbits at about 250 kilometers above the Earth. Teledesic's LEO satellites orbit at about 1,400 kilometers. By contrast, GEO satellites orbit at 36,000 kilometers. That's 25 times the distance of Teledesic's LEO satellites and 150 times farther from Earth than the space shuttle. Geostationary satellites provide many valuable services, especially for broadcast applications, but because of their considerable distance from Earth, they cannot meet the fiber-like delays required for present and future two-way networks. LEO satellites can provide real-time interactive communications. This is important for voice as well as many internet applications. LEO satellites provide seamless compatibility with ground-based networks. The point is for the application not to know it's going over a satellite. There are three major types of LEO satellite systems. The little LEOs, like Orbcomm and Vita, are the satellite equivalent of paging. The big LEOs, like Iridium and Globalstar, are the satellite equivalent of handheld cellular service. And the broadband LEOs, like Teledesic, offer the satellite equivalent of optical fiber connections. Just as cellular and fiber networks are not competitive on the ground, these LEO systems offer fundamentally different services. The third issue is, why use the Ka frequency band? Lower frequencies have become congested. The Ka band is the lowest frequency band with the capacity to support a global broadband network. Teledesic will operate in 500 megahertz of the high-frequency Ka band of the radio spectrum. The low orbit and high frequency allows the use of small, low-power terminals and antennas, about the size of direct broadcast satellite dishes. Most users will have standard terminals with two-way connections that provide up to 64 megabits per second on the downlink, with a return link of up to 2 megabits per second. These terminals will provide access up to 2,000 times faster than today's standard analog modems. For example, transmitting a set of X-rays may take 4 hours over one of today's standard modems. The same images can be sent over the Teledesic network in 7 seconds. Fourth, why use a high elevation angle? The Teledesic network is designed so that from anywhere on Earth, a Teledesic satellite can always be viewed nearly directly overhead. This is ensured by having an elevation angle of 40 degrees or higher at all times in all locations. Signals at high frequencies can be blocked by rain, especially when sent at a lower elevation angle. Teledesic's 40-degree elevation angle is essential to the network's high availability and quality of service. Teledesic's 40-degree elevation angle also enables users to place terminals on most offices, schools, and homes with an unobstructed view of the sky in all directions. A lower elevation angle dramatically increases the likelihood of obstruction, preventing service. Thus, lower elevation angles greatly limit the potential sites for terminals. In many areas, a low elevation angle can make any service impractical or simply impossible. Teledesic's 40-degree elevation angle is essential to meeting the company's goals for high quality of service. It also reduces the user terminal size and cost and improves the ease of sharing with other systems. Finally, why does Teledesic need a large number of satellites? When you combine a 40-degree elevation angle with low Earth orbit satellites, geometry takes over. LEO satellites move in relation to the Earth, so to provide continuous coverage to any one point on Earth, Teledesic must provide global coverage. All parts of the world will get the same access to advanced communication services on day one of service. This is especially important to areas that would not be economical to serve by other means. The Teledesic network will consist of 12 planes, each with 24 satellites, for a total of 288 satellites. The result is affordable, worldwide, fiber-like access to telecommunication services. The Teledesic network supports bandwidth on demand, allowing a user to request and release capacity as needed. This enables users to pay only for the capacity they actually use, and for the network to support a much higher number of users. The Teledesic network is designed to support millions of simultaneous users. Teledesic will develop alliances with service provider partners in countries worldwide, rather than marketing directly to end users. Teledesic will enable service providers to extend their networks, both in terms of geographic scope and in the kinds of services they can offer. Teledesic uses a global network to enable local service. Up until very recently, nearly all communication satellites have been GEOs. Today, most GEOs use spot beams to focus their capacity on the richest markets. Because Teledesic satellites move in relation to the Earth, Teledesic provides the same quality and capacity of service to all parts of the globe. In this sense, Teledesic's Internet in the Sky is an inherently egalitarian technology. On day one of service, Teledesic will help transform the economics of telecommunications to enable universal access to the Internet